Got it, guys. I have printer ready.
Okay, we've got 1:30. Why don't we get started? Good afternoon, Research Methods.
Good afternoon.
All right, all right. There's some enthusiasm. Who's ready for a weekend? Yeah, all right, we're ready for a weekend. Yes, it's been a long 12 weeks, and 12 week itself. Week number 12 has been a little bit on the long side, so I'm sure we're all looking forward to some REM. Today we're going to continue our conversation about complex designs, and just to remind you that we are right on track with the syllabus. For Monday, if you would please watch the video that's now available out there. It'll be on eta squared power and how we compute the factorial ANOVA. So that's in the usual place on Blackboard. Please.
Is there PowerPoint? Because I saw the video had been uploaded, but I didn't see PowerPoint.
Ah, okay, I'll have to check that. There should be one. Okay. But thank you for saying so. Okay. All right, really good. So that will be on track for Monday, and then later on that week we have our section exam just before we go away for Thanksgiving break, and I'll say more about the section exam on Monday. Okay. All right. Really good. So what I'd like to do is make today a rehearsal section, a time for us to practice what we've been doing. Thank you all for your homework assignments. I've got those right here. Look forward to grading those and getting those back to you very quickly. I wonder if we might start out this way. The very first question was on the issue of a between subjects design, and you were asked to create an experiment. And it could be an experiment on anything that was of interest to you. So what I'd like to do is invite people to come up. Maybe we'll have 4 people or so come on up and draw a graph of their experiment. And then we'll do some SPSS work on those graphs to the best of our ability. We'll create some dummy data, and we'll see if we can remind ourselves how we do one-way ANOVAs between, one-way ANOVAs within. Maybe we'll get a chi-square in there, and then we'll also wrap up by doing some of the factorial practice exercises. So I wonder, do we get 4 volunteers who would come up to, maybe we can have one person here, one person there, and 2 people on the backboard to draw a picture of their graph for problem 1, which was the between subjects experiment that you'd like to run. Any volunteers? Okay, yes, thanks. You can go any of those positions. I'm hoping to get several people up at once so you don't feel like you're that on the spot. Some other folks want to come up and just put up a graph that represents what they had written for number 1. This was between subjects an experiment. Somebody else? I could pull out the random number generator. We could do it that way. No, not the random number generator. No, it doesn't have to be the exact numbers. Yeah, we want to get the ideas up on the board. Okay, thank you. Natalie, if you can come on. Mark, would you go to just the backboard just so we can spread it out a little bit? Okay, thank you. Somebody else? Can we get a 4th person? And then maybe we'll get 4 other folks to do this for the within subject bit. It would be really easy for me to pick a winner. Oh, can't we do it by volunteer? No? Oh, okay, thank you, Mira. All right, thank you, Mira. All right. Just in case you were wondering, the winner would have been Meg. Okay, you would have been our winner. All right, really good. Thank you all for volunteering. Grab a marker. You're not being graded on this. We're just trying to break the ice a little bit. Hello, June. While we're waiting for them to finish their graphs, I'm just curious, can somebody call out some of the topics that you were investigating in this first bit? Anybody want to share with us a topic that they had tried to graph and create all that? Yeah, thanks, Catherine.
Well, I was looking at if test scores increased or decreased, whether or not people were studying with their phones on loud, vibrator off.
Okay, so our dependent variable is some kind of test score, and then we have 3 different phone settings. Okay, all right, okay, that works. Go ahead, Jenna, and then we'll come back to Katie.
Did you do the same thing? Kind of. I looked at classical, reggae, and rap.
Okay. All right, so the issue here is the musical genre going to affect recall? Okay. Katie M, I think, had her hand up, and then Rachel. Yeah.
I looked at how fast people would drive when they were listening to either rap music, country music, or classical music.
Okay.
Speed limit.
Okay, I got the 3 different genres, and what was the speed limit?
Or like just how fast you're
How fast you're driving, okay? Has anybody had that experience? They tend to accelerate a little bit under certain kinds of musical influences? Yeah, okay, okay. Yes, Katie B, or other Katie.
I did like how like studying types affecting test scores. So I did my 3 groups were studying with a tutor, studying with like peers, and studying by yourself.
Okay, all right, so the different kind of study situations. Okay, all right, that works. Yeah, some people are really good group studiers, others not so much. Kip's got something. Oh.
The effect of eating breakfast on cognitive performance in adults.
Okay.
3 conditions were like a full nutritious breakfast, like bacon, eggs, and fruit. And the second group was cereal, and the third group was no breakfast.
Okay.
And the other variable would be like scores on a cognitive performance test or something.
Okay, that's our dependent variable. All right, so does having a good breakfast matter? I think I promised Rachel a moment ago, and then I skipped. Yeah.
I don't know if mine is right or not, but I did different types of sweets and if they improved mood or not.
Okay, so we have a mood index, okay, and different kinds of sweets. All right, okay, that works for us. Anybody else have something they want to share in the between subjects variety? No? No? I think that works. It looks like we've got 3 conditions. Looks like we've got scores. That's more neatly than I would have done it, that's for sure. So, really good. Okay, so just because Meg's happens to be finished first, why don't we visit this one? Can somebody other than Meg give us the script for this graph? So we have a script for reading graphs. Starts out in this graph, and then how do we do that? Okay, thanks, Katie.
In this graph, the score is plotted as a function of room lighting.
Okay, and we stop right there because we don't have another. Is that what you were going to say, Hannah? Okay, all right. And so we're looking at the quiz score, and we have different kinds of lighting conditions, and it looks like dimly lit is working best for us, at least hypothetically here. Okay, all right. Did you have some reason to think that this actually would? I mean, have you experienced that? Do you think you perform better under certain lighting conditions than others?
Yeah, I think it depends. I mean, I would expected no light. I mean, I did a random.
Okay.
I expected no light to be lower.
Okay. One of the things I was going to have us do today, I was going to have us do a couple of computer exercises where we do online computer tests. And some of my students in sensation and perception are doing a color sensitivity test. And they actually went out to Walmart and they got 2 different lamps. One of the lamps contains a fluorescent bulb. The other one contains one of these broad spectrum lights that tries to simulate sunlight. And they looked at the extent to which you can do color sensitivity tests under the 2 different lighting conditions. Unfortunately, they came up null. They didn't find a difference. But it felt really good being in the sunlight, but it actually didn't affect behavior in any measurable way. Okay, thanks. Why don't we go to the back of the room? I'll go all the way back here. We'll spin around just a little bit. And I don't remember who is where. Mira is one of the ones back here, I think. Mm-hmm. Is this one? Are you all the way? Okay. All right. So this is memory fondness of childhood? Okay. So is this something like how fond is the memory of oh, okay. So we're getting a fondness scale here, and you're asked to think about childhood in general, or first day of class, or okay. All right, childhood in general. All right, and then we have age group. This is kind of interesting. All right, and so the idea is that as we get a little bit more distance between our current state and our childhood, we remember things a little bit more cheerfully, perhaps. Is that the idea? Okay. By the way, how many people think this would be the trend that you would find, that folks tend to look back over longer periods of time more fondly, and if it was a more recent memory, it's not so fond? People think they'd probably find it that way? Okay. All right. Very good. Okay. And this would be most effectively done as a between subject. You could do this longitudinally, but it would take you almost 30 years, I guess, to get there, right? Okay. All right. Really good. All right. And over here we had Who else? Oh, yeah, Maureen, thank you very much. Number of points improved as a function of depression.
Oh, mine was the effect of like Prozac on the number of points improved on like a depression scale test.
Okay. Okay.
So I didn't know how to write that all over.
Oh, okay. All right, so this is a depression indicator, and we're getting, so higher scores here are better. Okay, right? And the idea is that our mild depressed group is going to be showing the most improvement, more so than severe, and not so much from none. Okay, okay. And are these folks are all getting an antidepressant, or okay? Because it's not entirely clear what the manipulation is, right? So these.
They're all getting, I think I wrote down 10 milligrams.
Okay, right. So they're all getting that, right? And then we're looking at their improvement. These appear to be natural groups, right? So they're of course these appear to be natural groups also. Okay, okay, that seems to work. So here we have an example of a between subjects case that might be just one factor, okay, and it's got a natural groups design. All right, thank you. Thanks to all of our folks for participating and going up to the board. I think that's the first time this semester we've had students writing on the board. Appreciate your doing that. Why don't we see if we can now begin to connect some of these things, and we'll spend a moment inside of SPSS. If you'd open up a blank SPSS, I don't have a preconceived data set on this. We'll have to see what we can do. Why don't we let the group decide on which of these we'd like to investigate? Doesn't matter to me. We can do an investigation on any one of these. Somebody want to yell one out? Okay, room lighting is what some folks are looking for. So we're looking at some kind of quiz score. We'll have room lighting as a condition, and we're going to have room lighting as our variable. We'll have 3 different conditions, okay? All right, so why don't we open up a blank data sheet inside of SPSS, and it'll look just like this, okay? We won't dial into anything, and we'll try to create this new. This, by the way, is sometimes a difficult step for students who are in a 200-level research course. They have some idea about what they want to investigate. They could probably draw the graph for it. And then trying to get from here to here is a bit of a transition, right? So we'll have to think a little bit about how we might do that. So I'll let you instruct me. How might we get from there to there? What kinds of things do we need to do over here in SPSS? Thanks, Kip. Okay, we'll always start that way. At least warms us up a little bit. So let's put in participant. Okay. Any other tricks along here? Okay, and if we do, then we can call them by some kind of a name. We could have other string variables as well, but we might have, I don't remember what that was, maybe 6 people was supposed to be what was in this particular one for number 1. We can go with more people than that if we want to. It was 5 people on the first one, okay. So we can go with some number of folks here, okay. All right, that all works. Okay, what else might we do here? So we're looking at this one, and this was the script that we read. In this graph, quiz score is plotted as a function of room lighting. Okay, what else do we need? Can we all yell out? Okay, we're going to need some kind of quiz scores. That's true. We need to be back over here in variable view. We'll put in quiz score. All is one word. And just so you can see, if we try to put in quiz space score, I think it'll yell at me. Okay, it'll yell at me and say you have illegal characters, right? So quiz score has to be all continuous. Okay. And we might make the measure maybe a scale variable, okay? And our quiz score might be some number between, presumably, well, here it's between 0 and 10, okay? So we can do it that way. And we'll get some simulated numbers in just a little while. That's our quiz score. And what else do we need, if anything else? We need a group variable, okay? Or a room lighting variable. That'll be our grouping variable. Okay, put that in. Anybody want to help us out with this? What?
Somebody did like the well lit is 1.
That's okay. And where do we do that? Let's all yell it out. That's exactly what we need. Values. Let's click on values, and you can do it like me, or you can do it some other way. But I'll go with what Rachel was suggesting, which is 1 will be well lit, and then dimly lit. It will be 2. So let's go ahead and get those going. And these can have spaces in them. Okay, and then we have no lights, or no light, number 3. Okay, do we need, I think that's all we need, right? Now, of course, we're going to need some data in a moment, but at least for right now, we've got that going on. All right, so now if we click on data view just for a moment, you can see that we've got space for participants, and we've got space for quiz scores and room lighting conditions. Okay. We have 3 conditions. Why don't we get some number of participants that will be a multiple of 3, but not really big data sets here. Maybe we can get something like, why don't we do, can we do 15 participants? Is that okay? All right. So if we go over here, we'll put in P1, and we'll go all the way down to P15. while people are finishing that up, I wonder if somebody can help us think about what our next step might be. We could do quiz scores. I wonder if, for a moment, could we just jump over to lighting, and can we, how should we try to allocate who's where? We'll go with equal group size. Hannah has an idea about that?
We put the first 5 with well-lit.
Okay.
And then the next 5 dimly-lit, and the last 5.
Okay, so why don't we go in sets of 5? So I'm going to put in a 1, and that converts to a well-lit. You might need to toggle back and forth between your value labels on or off, but I'll turn my value labels on, and I'll put that in now. I'm putting in the number 1 and I'm hitting enter, and then I'll put in the number 2 5 times and the number 3 5 times. Okay, and that's at least one of the ways of doing this. On Meg's scale, we went from 0 to 10, so we'll have to think about some ways of getting those numbers. And what we could do is we could just make up some numbers and everybody stick with them, right, and see what we get. Or we could all do different random numbers. That might be fun also. What would you rather do? Should we all do one data set, or should we do our own random numbers? What do people have a preference for? Okay, all right, we're mixed. Why don't we do one example one way and another example another way? Why don't we get some random numbers from here? So let's do it this way. If we can minimize this, okay, and we'll click on Excel. Okay, and we want to get some random numbers in between 0 and 10. Does anybody remember the command for doing that? Rand between. Wow. All right. Equals rand between. Rachel showed up to play today. Rand between. Okay. And we want to do 0, 10, enter. And there's one number, but if we drag it down to number 15, we get 15 such numbers. Okay. And mine will be different from yours. As you hit the F9 key, yours is different from everybody else's, and different tap over tap. We get a brand new set. Okay. So what I'm going to do then is get these 15 numbers. Let me just check in. How many people have that? We've got random numbers between 0 and 10. Okay. And now can we highlight all of those and go Control C? We'll get that ring around the rosy. Okay. And then we'll come back over to our data set. Okay. And if I have my spacing right, I can plop those in under quiz score. And I now have 15 participants, 5 in each of 3 conditions, excuse me. And then everybody's got a score that landed somewhere on the scale that Meg has given us. Who's got that? All right, questions so far? Making the transition? Okay, now what we want to do is we want to go from the idea that she had to a graph that she has. We have the data as variables. We have the data as for each of our participants. Why don't we see if we can go on and do an appropriate ANOVA? Can somebody help us out with what we might click on? Analyze, then what happens? Which one is it? A little confusing. This is a between subjects case. We're going to do compare means, okay? And then we can do a one-way ANOVA. Okay, compare means one-way ANOVA. Okay. And somehow I'm not getting a grouping factor. Let's see what we have to do. Let's cancel out of that. Let's go back over here and quiz score. Oh, I think that was right. Okay, analyze, compare means, one way. Okay, our factor is going to be room lighting. Does that work for us? Okay. And then here's our quiz score. That's going to be our dependent variable. How many people have that? Does that work for us? Okay, and then another thing we can do, maybe a couple of post-hoc tests. Okay, why don't we do post-hoc? And we could take a few of them here. Why don't we take the regular Tukey? Why don't we take Chaffee? We could take Bonferroni if we want to, but we'll go with Tukey and Chaffee just for right now. We'll say continue. Let's see, any other things that we want? Let's go to options. Okay. Why don't we get some descriptive statistics? And why don't we get some homogeneity of variance test? And that's going to be called what when it comes out? Levine's test. Okay, does that sound familiar? Okay. And let's see if I lost anybody there. I'm doing the options. I clicked on the options button, descriptive and homogeneity. Okay. We'll say continue. Okay, and we'll say okay, and we'll see what we get for this dummy data set we just made up on the fly. Now, of course, your numbers are going to be different from your neighbors. Your numbers are going to be different from mine because we all put in random numbers that we have here. But structurally, how many people get some output that looks something like this? Even if the numbers are different, you'll have that box, this box, and your specific values will be different from your neighbors and different from mine. Okay? We get some idea I'm looking at the means, and I'm not seeing a lot of variability. I'm getting 4, 5.4, and 4.6. Is anybody getting a strong difference in any of their conditions just by eyeballing it? Probably not. Okay. All right. Now let's take a look at this. This is kind of interesting. We're taking a look at the homogeneity of variance. Will somebody help us with the interpretation that we have up here, which might be different from yours? What's going on in this case? Homogeneity of variance. Somebody help us out with that interpretation? Okay. Yeah, thanks, Jenna.
Well, in that case, you can reject the homogeneity of variance as being the same as less than 0.5.
Okay, right. So in this particular case, I just used some random numbers. It turns out that, at least in the random numbers that I generated, one of these error bars is way different from another one of those error bars. Or it might even be that there are a couple of them that are very different from each other. Who's following that? Okay. So Meg drew this very nicely, and those all look approximately the same. This one's a little bit bigger, but not a whole lot. That's probably going to be, one is, oh, I see. That's a 1 unit and a 2 unit? Yeah, okay, very good. So that's actually, that might be enough to break the equal variance assumption. We'd have to run the test on it. But in my particular case, I got a significant violation of the homogeneity of variance assumption. By show of hands, how many people have a sig value higher than 0.05 here? And does anybody else get one that's lower than 0.05? Okay, so me and Mira were the only ones who happened to get that just by chance, okay? So we're going to pretend that we're going to go right ahead, and we'll take a look at the output that we have here. And looking at mine, what kind of conclusion might we draw about the null hypothesis? Retain or reject the null hypothesis? We're going to retain because the sig value is greater than 0.05, okay? So that makes the comparisons down here somewhat uninteresting, but we could have done each of the pairwise comparisons, and we get a sig value for each of those. These are now adjusted according to the Post-Hoc of either Tukey or Schiff-A, okay? All right, so in my particular set, I didn't get a difference. Just out of curiosity, did anybody happen to generate a difference? If we look at your ANOVA value, did anybody come up with a sig value less than 0.05? There's a reasonable chance that if we have 20 people doing it, somebody would come up different just by chance. Looks like none of us got there. Yeah, please.
If the sig value was below 0.05, is that when you go on to the Post-Hoc test?
Yeah, right. And there's really no need to do it if you haven't, if this is telling you that none of the differences are significant, then the Post-Hocs really become irrelevant. Right? All right. But we took that precaution just in case we happen to have found significance. All right, so we went from an idea to a graph to lots of numbers where we can test equal variance assumptions, and we can test equality of means and so forth. All right, really good, really good. Questions about any of that? Okay, all right, why don't we put this one down, at least for a while. We can minimize that. And why don't we go on to a second idea? So this next question was question number 2, and it challenged you to think about within subject designs. So I wonder if we can get 4 other people, hopefully no repeaters, to come on up and share what their graphs look like. And then we'll take a look at those variables, and we'll run a different kind of ANOVA. We'll have to create those differently. You'll see that the structure is different inside of SPSS. And we'll remind ourselves of what we click on and how the 2 kinds of one-way ANOVAs differ from each other. And then we'll go on to the factorial case after that. Do we have any volunteers to come on up to the board? Maybe we can get 4 people to come on up and do their within subject analysis. Thank you, Kip. You can take either board. Somebody join Kip. Anybody willing to come on up? We don't want to go back to the random number generator, do we? Let me just call it up. Seeming to bring it up is usually enough to get some people to say. Come on, any volunteers? Okay, thank you, Maddie. You can go to front board, back board. If you want to erase one of these and just write over top of it, that's fine. Oh, please, yeah, if you need to grab your sheet, that's fine. Okay? So these are all within subject designs. We call them repeated measures designs. What is our motivation for using a repeated measures design, by the way? Why do we bother with that? Anybody? We can eliminate consistent individual differences, and if you wanted to be more specific, within the formula, we'd be pulling them out of the denominator, and that makes our F ratio bigger. Okay, we're half the way there. We've got 2 volunteers. Thank you, Maddie, and thank you, Kip. Anybody else want to come up and offer us a within subject design? Okay, thank you, Catherine. Hooray. All right. Okay, thank you, Katie. If you would head on back. It's really not that bad. I've been doing this all semester. Yes, please, if you need to pull your item out, that's fine. We wouldn't know if you're not representing your item well, we wouldn't know. It's a secret to all the rest of us. Just in case you want to know who the winner would have been. Ooh. you would have been the winner. All right, so within subject designs, as these are going up, can some folks share with us some of the ideas that you had? We won't ask you to graph them. Folks want to share some of the ideas that you had in the within subject or repeated measure case? We'll go with Rachel.
I did like hours of sleep and reaction time.
Okay, so I'm one of your participants. You're going to be measuring my reaction time, and you've got me in 3 different hours of sleep conditions.
Yeah, I did I did like 3 hours, 6 hours, 8 hours, and 10 hours.
Okay, and so just how does this all work? So do you have me go on 4 nights and you wake me up after 3 hours or 10 hours or?
It was just like one night you get 3 hours sleep and then you're supposed to live, and then the next night, yeah.
Okay, so you wake me up, you sort of interrupt my sleep. Okay, I mean there are really interesting sleep studies that are done on this. They have you wired up on an EEG, and as soon as you go into REM, for example, they wake you up and they allow you to sleep, but not in REM specifically, and they measure how well your performance is when you're not sleep deprived per se, but you are REM deprived. Okay, all right, really good. Thank you, Meg. Meg's got one, and then we'll go to Hannah.
I did like how whether or not like depression increases or decreases going through like a therapy program.
Okay.
So like my levels were I gave them a depression test for right when they entered the program, like before they entered the program, 6 months into the program, a year into the program, and after they left the program.
Okay, so we have different time intervals, okay, right? And that's always, time is always one of the ways of getting repeated measures done, okay? So same people are sampled at multiple times, whatever those intervals might be, okay? All right, Hannah, did you have one?
Yeah, I did the effect of different types of exercise on memory.
Okay.
That was kind of like fun.
Okay.
So I had no exercise, and then a memory test, and then walking, memory test, running, memory test.
Okay, all right. Okay, so a couple of different varieties of exercise, and not that I asked you to do this, but we'd want to think about counterbalancing this, because maybe you get better at taking the memory test, maybe you learn some tricks, or you recall some of the mnemonic devices that you learned in Psych 100, right? So we want to make sure that's all separate and apart from what goes on in the exercise routine. A couple of years ago, we had a major researcher, his name is Arthur Kramer from the University of Illinois, Urbana-Champaign, come and talk to us about that relationship, aerobic exercise and cognitive performance. And he's really big on that. He claims that's the best thing you can do for your memory. It's not taking these tests where you do puzzles and things like this. It's actually going out and taking a lap. Will do more for your memory than practicing certain kinds of memory exercises. Okay. So let's see who's where. Who's got this one?
I none.
Okay, Catherine's got this one. Can you walk us through, Catherine?
Yeah, so I was testing kind of like Hannah's, the difference between like before you do any exercise versus after and your attention span, so
Okay.
how long it is.
Okay, really good. Okay, so I'm going to be I'm your participant. I'm going to be in all of these conditions. I'm not much of a swimmer, so that'd be a sight to see, but okay, nevertheless, I finally make it across the pool, and then you give me some kind of test of attention span. Did you have an idea about how that might be measured?
Well, I was thinking about just doing like the difference between like, I would do a test before they swam and then a test after they swam.
Okay.
And then seeing like the difference between how, like if it affected their attention at all.
Okay, right. I'm thinking that you might be able to use something like the visual search test as their attention span measure. I'm not sure if you had an idea about what the test itself would look like. Okay, okay. All right, that's fine. Thank you. All right, over here, who do we have? Okay, thank you, Maddie.
I did like the effect of certain foods on your happiness level. So like you would eat that specific type of food, and then you would rate your level of happiness.
Okay, all right, really good. And so we've got these. So I'm going to be in all of those conditions. All right, and ice cream makes us happy, is what we think we see here. Okay, all right, that works. That works. Okay, let's go on back and see who joined us back this way. Okay, Kip was in blue. Why don't you go ahead, Kip?
I wanted to study the effect of ADD treatment or medication on children, on cognitive performance with kids who have ADD.
Okay.
So the conditions of the independent variable are like before treatment, after a week's treatment, 2 weeks, and 3 weeks.
Okay.
And the dependent variable is the school.
All right, really good. So another time-related variable, and that's always going to work well for repeated measures. Okay, so that's going to be done very, and it looks like they're getting better across time, at least as we have predicted here. And we also have roughly equal variance. okay, which is especially important had this been a between subject design. It's nice to see in the within subject case, but it's actually not one of the requirements, but there it is anyway. Okay, and our last, who did we, okay, thank you, Katie. Yeah.
Mine was actually similar too because I did antidepressants though.
Okay.
So I did like dosage, like if a higher dosage of antidepressants like affects your response rate.
Okay, and this is maybe 1, 2, 3, and 4 milligrams of some antidepressant? Okay, and what is the response actually? What?
I don't know what the response is, but like I guess my numbers were like in seconds.
Okay, all right, so.
I didn't really think about like what exactly happened when you had them.
Okay, so it's interesting. If it is a response rate in seconds, then higher scores would be more seconds? Is that right?
A higher dosage would be
A higher score, if I'm
or higher
higher response rate.
response rate would be associated with a higher dose.
Okay, right, okay. And so if the response rate is measured in seconds, oh, maybe it's the number of responses per second? Maybe that's what we're doing? Okay, because otherwise it looks like we're actually getting slower. That's just time. We're getting slower with the higher dosage, which is probably counterintuitive, but okay, I guess it depends on how you've operationalized your dependent variable, but okay. All right, really good. Okay, and then the other idea is that in all of these cases, you generally want to counterbalance across your conditions unless you can't. In a time-related variable, you can't do 3 weeks before you do 1 week. But over here, you actually could mix up the dosages. And you could have me start on 4 and then later on go to 2 and 3. You're mixing the dosages around, okay? Which is something that we frequently like to do in repeated measures to avoid these carryover effects when it makes sense to do that. If you've got a time-related variable, you can't do that. Okay? All right, so some good design issues there. All right. Let's think which one of these we want to take off to SPSS, and we will need to design this a little bit differently in SPSS. Which one shall we do? Food? Okay. We want ice cream? Is that what it is? We want ice cream. All right. So why don't we go back into SPSS? We'll get to the data side of the house. Okay. And we could even go File New if we want to. And by going File New, we come up with Tabula Rasa, the blank slate. How many people got that? Or you're able to get a blank bit? Okay. All right, let's start out with variables. And it looks like we're doing the ice cream bit, so we're going to wind up with, actually, it was the food bit, and ice cream is one of 4 levels that we're going to need. And we'll do this one more time. How do we always get started on variable view? Participant, and we'll turn that into a string. By the way, your participant could be a non-human. And this was Maddie's, is that right? Okay. Did you think that these would be humans as participants, or do you think these could be rats, or you were thinking humans? Okay, all right, that works. All right, we'll figure out how many participants we have. Some of the other variables include, looks like carrot, bread, ice cream, and none. Okay. So I think what we'll wind up doing, well, you tell me, how would we like to organize this? What kinds of things should we put in here? Okay, we could put in food. We could put in food type, right? And that's probably what we would do if this were the case that this was a between subject design. Okay, and so some of the people would be in this condition. We would call that group 1. Some of the people would be in group 2, group 3, and group 4. So we'd have one variable that has 4 levels. Okay, actually, what happens now is for any one participant, if I'm understanding this correctly, we're doing this within subjects, and we actually need to have. Let's just say that. Sasha is one of our participants. Sasha has to be tested in all of these, right? And within subject design, she smiled because now she knows she's getting ice cream, okay? So she has to be in all of these conditions. That's our definition of a repeated measures design. Does that work for us? So we do have to structure this a little bit differently. What we're going to do here is put in each of these words as its own variable. So those words, again, are carrot, bread, ice cream, and none. Can we put those in? One variable is called carrot. Then we have the bread variable, ice cream, and remember these can't have a space, and none. Okay? All right. Why don't we do something like maybe 20 participants? Okay, we'll go over here to data view, and we'll put in P1 through 20. And now each of our participants who's come to us maybe through the SONA system gets exposed to each of these, and then they're rating how happy they are shortly after having some quantity of each of these, or having none. Yes, please.
I'm putting down P1 because it like erases.
It erases. Why is it erasing? Anybody want to help us out?
Oh, I didn't put straight.
We didn't put the string, okay? And SPS says if we're going to put in, had you put in the numeral 1, 2, or 3, it would take it. But if we do want to put in letters, then we do need to have that as a string, okay? So thank you for pointing it out, actually. Okay, that helps the whole group. All right, so now we need to get some data here. And what kind of a scale did Maddie have? It goes from 1 to 10, okay? We could do 1 to 10, all right? Why don't we cook the books here a little bit? So which one do we think is going to be the winner? Ice cream is probably going to be the winner. So why don't we do it this way? We'll allow people to put in any number they want. Why don't we put in, randomly as we're going down here, 8s, 9s, and 10s. We'll let you put those in any sequence you want, but in ice cream only, we'll put in 8s, 9s, and 10s. In no particular sequence, you can put in a bunch of 8s, a bunch of 9s, so I'm cooking the books. Okay, and we've got 20 scores there because each of our 20 participants was in the ice cream condition. Okay, let's go with carrot. I actually like carrots, but what do we think if we had so here we used a 3-stroke range, 8, 9, and 10. What should our 3-stroke range be here for carrot? 0, 1, 2? Is that what we got? Hannah doesn't like carrots very much. Okay, we're going to go 0, 1s, 2s. Any sequence that you want there of 0s, 1s, and 2s. Okay. So carrots might make us unhappy. Okay. Bread. Well, it might depend on what kind of bread. We'll let you finish on the carrots. Somebody want to throw out I'll call it a 3-stroke range for bread?
6 to 8.
6. Okay, 6 to 8. Okay, that's going to give ice cream a run for its money, but all right, let's try that. 6, 7s, and 8s. Okay, now just because you've gotten no food doesn't mean that you're completely unhappy, right? We're not actually rating the taste of this thing. If I understand Maddie's variable, we're rating our happiness level, right? So, for example, you might have come in and been elated to learn that we have a test next Friday, okay? Even though you didn't eat any food, right? So maybe your mood goes way up just because you hear that we've got that good news going on. So we don't need food necessarily to have a high level of happiness. So what should be our 3-stroke range here? Anybody have an idea? Throw something out. 3, 4, 5. Should we try it that way? 3, 4, 5. Oops, excuse me. Okay, so now no two of us will have exactly the same data sets, but we'll probably have very similar data sets, I might guess. One of the things we've done is we've kept the same 3-stroke range, so we're going to have fairly similar variances, I might imagine. Okay. All right. So now we're going to try to perform a one-way ANOVA, just like we did a moment ago, except this is between subjects. So anybody want to remind us how we do this? I'm sorry, this is within subjects, excuse me. This is within, it was between a moment ago. How did we get started? Analyze, okay. You'd think it was compare means, but actually it's something else. Okay, yes. General linear model repeated measures, okay? I'll let you go that far. I'm going to leave that up so everybody can see that I went analyze, general linear model, and then repeated measures, all right? And then once you click on that, you get a submenu that I'll bring up now, and there it is, okay? Somebody want to name our factor? We can put in a more friendly name than factor. Okay, we can call it type of food, okay? Or food type, something like that. Okay. How many levels do we have? We have 4 levels. Does that work for us? Okay. And then we'll go off to define. And now we actually don't need to track the participants, but we can grab these 4 levels and we can slide them on over. And I'll pause just to make sure everybody is still with me. Sometimes I get a little bit ahead of the group. Anybody stuck? Okay, so now we have these, these 4 bits. All right, why don't we take a look at the options? Okay? And why don't we highlight all of that? And we'll get means for the overall mean, and we'll get a mean for each of the food types. We can get some descriptive statistics. We can get some measures of effect size. We can get observed power. Doesn't really mean a whole lot to us right now, but when you watch the video on Monday, we'll get some of that. Okay? All right, and post-hoc tests, if I go here, it turns out we don't get any options. Anybody remember why we don't get options? We had options a moment ago. Oh, go ahead. Right, it doesn't do a post-hoc test for repeated measures. Okay, so how do we do that then? How do we perform post-hocs on repeated measures if SPSS won't do it for us? Anybody recall? Think I hear it? Yell it out. We do some t-tests, and they're corrected by a very Italian-sounding kind of name. Bonferroni. Okay, all right. All right, so we'll have to do some Bonferronis in just a moment. So here we've got these, and we're ready to click on OK. Okay. All right. And so now we'll drop all the way down, and we can look at a few different items. We could look at, here's one. Okay. All right. We've got this kind of bit. Why don't we go to Mauchly's and see if anybody wants to help us with the interpret. Yours is probably a little bit different from mine, but in general, can somebody help us out with what we do inside of Mauchly? Who remembers that? Thank you, Jenna. Yeah.
Well, you look at the sig value, which
Okay.
For me is 0.74.
Okay.
0.5, so that's not statistically significant. So you're going to have to retain the Nelson's sphericity.
Okay, right. So that is, we're going to retain the sphericity assumption because the sig value is greater than 0.05. We retain. Had it been lower than that, we would reject. If we had rejected, what would we do when we came down here to this box? We would use the next one down, but now we can assume sphericity because our assumption is safe according to Mauchly. We can retain that equivariance assumption. Okay, so let's go down and start looking at the actual sphericity assumed box within our test of within subject effects. We can come on over here, and I'm getting, wow, I'm getting a really big F value. Did anybody else get a really big, I've got 365 as my F value. Okay, how many people are getting more than a 200 in there? Okay, so that's a pretty big F, right? Typically, we have to get away from 0, past 1, and into maybe 3s, 5s, 7s. People are getting F values in the 200s or so, something like that. Okay, all right, that's working pretty well. All right, so it looks like one of these things is not like the others. Okay, questions so far? All right. Anybody want to remind us how we might go about doing our t-tests? We said that we wanted to do t-tests. So what would we click on inside of SPSS to get that going? Yell it out. Analyze, okay. Compare means, good. T-test is a comparison of means. Anybody remember which of these from the subset? We have compare means, and now we have a set of lots of different possibilities here. Actually, they're not independent samples, but that was a good guess. They're paired samples, right? That's their funny way of referring to within subject comparisons. Let's click on paired samples, okay? And now we can start contrasting one with the next. Okay, why don't we do a few of these? Why don't we compare ice cream to everybody else? I'll click on ice cream, and I'll send him over, and then I'll do ice cream versus carrot. I can make this bigger so you can all see. You can drag that. And then we can do, as our second comparison, ice cream versus bread. And then we can do ice cream versus none. Excuse me. I picked ice cream somewhat arbitrarily, but you can imagine you can have all different kinds of pairwise comparisons that go on there. Okay? All right. Who's got that? That worked for us? So we have ice cream versus all the competitor foods for happiness, and we can click on OK, and we drop down even further still. Okay? And why don't we take a look over here? Okay? And I wonder if somebody can help us out with this analysis. What do we want to do with this box, and what is it telling us? Some people are not sure what this is telling us. It's okay if you're not sure. Okay, all right, so here we're doing the paired samples t-test. We're comparing ice cream versus carrot, okay? And it looks like we're getting a t-value that's quite a bit different from 0. Here's our degrees of freedom. We have a sig value that looks like that, okay? So forgetting about the Bonferroni for a moment, will we normally retain or reject in this case? Reject, okay, so that would suggest that this hypothesis that we have, all means are equal, is one that we can reject. It looks like we're getting very different means in the ice cream and carrot case, and then also for each of these, we're getting a statistically significant difference. Ice cream seems to be significantly different from each of the other 3. Who's okay with that? Okay? Now, if we do make a Bonferroni correction, can somebody help us out with how we would go about doing that? We're going to start out here, and what did we do with our Bonferroni? It's been about a week since we ran the Bonferroni. Go ahead, Jenna, thanks.
You do number of t-tests that you did times degrees of freedom?
It's times the sig value. The sig value, okay, right? And how many t-tests did we do? Let's all yell it out. 3? Okay, so let's do 3 times 0, and that equals? And then over here, we have to do 3 times 0, and that would equal? And then over here, 3 times 0, and that equals? So after the Bonferroni correction, we still have significance. So Bonferroni will say you cheated, you did a few too many tests. We're going to move those boundaries out a little bit further. You need a more extreme t-test score in order to claim significance. But even after the Bonferroni correction, we're way past whatever we need to be past for statistical significance. In other words, ice cream wins big time. Okay? All right, that's what we've got there. Who followed all that? Okay? All right, why don't we do this now? Why don't we say that we're done for SPSS for the day? I wonder if folks could just offer a couple of comments on the last item that we had. We had you draw this A1, A2, B1, B2, and you had all these different pairwise comparisons for a factorial design. The 2 items that we've done so far have been one-way. We did a one-way between, we did a one-way within, and then we had this factorial kind of design that was a 2 by 2. I'm curious to know how many people found that to be challenging? Okay, all right. And that's the simplest kind of factorial design, all right? So why don't we see how we're going to do on that? I won't ask you to come up to the board. We'll just see if we can do a couple of these, okay? All right, I'm going to put A1 here. I'm going to put A2 here. Okay? And we'll create some kind of a scale for B1 and B2, some kind of a legend for that, okay? So we might do something like this. A circle might be B1, and a square might be B2. Here's a trick, just in case this comes up on an exam, you don't have to label this axis numerically. I find students really benefit if they do and they use these numbers. You might want to jot them down. It works really well if we go 9, 5, and 1. Okay? It goes really well if we do it like that. Okay?
Is this number 3?
This is number 3 from the homework, yeah.
I thought there wasn't supposed to be anything on the axis.
Okay, right, so you don't have to put anything here, right? You don't need anything here, but this might help you think about this. If you don't want to use numbers, you don't have to, but it might help you, and I don't care whether you've got numbers there or not. You don't need them, but I think it will help you think it through, okay? All right, somebody want to throw out a combination that they found troublesome? So we can always say this. We're always going to be looking at factor A, factor B, and A by B. We'll do 1 or 2 of these, and then we'll call it a day. Here's A by B. And sometimes all of these are turned on. Some of them are turned on conditionally. Please go ahead.
I thought number B was really difficult.
Okay, and which was the sequence there?
Factor A is significant.
Okay, it gets-
Factor B is non-significant, and the AB interaction is non-significant.
Okay. Oh, and that's non-significant. Okay, so this one strikes us as being particularly tough. Right? This is non-significant. Okay, so non-significant, but factor A is significant. Okay? All right. So we need some way to handle this. Somebody have an idea about that? What that might look like? Anybody want to try to draw it maybe in the air, what the pattern might look like? Please go ahead, yeah. Okay, so I think I see they're doing, you went like this and this? Is that what that was? Okay. So we're looking only for factor A to be significant. Right? Only factor A. Okay, so if they're both like that, it looks like B1 might be up here, and B2 might be around here. Okay, so so we're looking for factor A to be significant. How about this? so what happens, and if you want, I can draw this on just like that too. Okay? All right. What's our mean for A1? 9. What's our mean for A2? Okay, are those different from each other? How do we do? Okay, right. Okay. Do we have an interaction here? No, we don't have it, and we're not supposed to have an interaction. How are we doing on B1 versus B2? Pretty complicated or not so complicated? Ridiculously simple, right? But sometimes it's hard to find something so simple in what looks like it's complexity. Okay, we're at 2:20. Why don't we do a few more of these on Monday when we come back? Please watch the video. Thank you, Maren, for saying that you didn't find the PowerPoint there. So I'll check that out and make sure it's there. Okay? All right. Have a great weekend.
How you doing?